Dear students, I am Preeti Kiran, PGT Chemistry, Kendriya Vidyalaya, AGCR. Today I am taking up your chemistry lesson. Before 18th century, when very few elements were known, it was very easy to study these elements and their properties. But with the discovery of many more new elements, it became difficult to study the properties of these elements. And it led to the need of the classification of elements and hence the periodic table. Today we will study about that what attempts led to the formation of the periodic table. Earlier attempts were based on the atomic weights. Dobronius said that the similar elements exist in the group of 3 elements, and he said these groups are as triads. Newland gave the law of octaves. Dmitry Mendeleev, the Russian scientist, his attempt was remarkable. He gave his law that is known as Mendeleev periodic law. The law states that the properties of the elements are the periodic function of their atomic weights. He gave importance to atomic weights. Mendeleev arranged elements horizontally in the order of their increasing atomic weight. He gave preference to the chemical properties and ignored atomic weight if some of the elements did not fit in as per atomic weight. Mendeleev periodic table. It consists of groups. There were 9 vertical columns from 1 to 8. Group 1st to 7 was subdivided into 2 subgroups A and B, and the group 8 divided into 3 sets, each with 3 elements. Group 0, which was consist of inert gases, it was not discovered at the time of Mendeleev. Periods or the series. There were 7 horizontal rows numbered from 1 to 7. They are known as periods. Period first. It has 2 elements. Second period, it has 8 elements. Third period, it has again 8 elements. And second and third periods together known as the short periods. Fourth period has 18 elements. Fifth period has 18 elements. Group 4 and 5, they are known as the long periods. Sixth period consists of 32 elements, the longest period. Seventh period, it has 32 elements, but still it is incomplete. The uses of the Mendeleev's periodic table. Each group has the elements with the similar properties, and it facilitated the studies of all the elements. Prediction of new elements. At the time of Mendeleev, there were few elements which were undiscovered, but Mendeleev successfully predicted these elements, and he left the vacant spaces in his periodic table. For example, Aka aluminium, which is nowadays gallium, and Aka silicon, which is nowadays germanium. Both the elements were predicted by Mendeleev and very rightly predicted. Doubtful atomic weights were corrected. Defects in the Mendeleev periodic table. Position of hydrogen. Hydrogen resembles in its properties the alkali metals as well as halogens. Its position was disputed and its correct position was not allotted in the Mendeleev periodic table. Anomalous pair of elements. Elements with a higher atomic weight was placed earlier or preceding the element with the lower atomic weight. For example, iodine with atomic number 127 was placed before tellurium with atomic weight 128. This was a defect in the Mendeleev periodic table. Position of isotopes. As we know that the isotopes have different atomic weights, but Mendeleev placed them together. There was no place assigned for the noble gases since they were not discovered at the time of Mendeleev. Henry Moseley, he tried to remove the defects of the Mendeleev's periodic table, and he proposed that atomic number is more important and more fundamental property than atomic weight, and he gave modern periodic table and the modern periodic law. Modern periodic law states that the physical and the chemical properties of the elements are the periodic function of their atomic number. He arranged elements in the order of increasing atomic numbers. The elements with the similar electronic configuration have similar properties. The modern day periodic table is also known as the long form of periodic table. The periodic repetition of the properties is due to the recurrence of the similar valence shell configuration after regular interval. Periods. The horizontal rows are known as periods. The elements have the same valence shell. In all, there are total 7 periods numbered from 1 to 7. Period 1. The principal valence shell, that is small n is equals to 1, the orbitals being filled up 1s, and we know that in the s orbital 2 electrons can be accommodated, so in total 2 electrons and the 2 elements in the first period. The second period, n is equals to 2, the orbitals being filled up 2s and 2p. The s orbital can accommodate 2 electrons and the p orbital can accommodate 6 electrons. In total 8 electrons and hence 8 elements in second period. Third period, n is equals to 3, 3s and 3p orbitals. Similarly, again 8 electrons to be filled up and 8 elements in the third period. Fourth period, n is equals to 4. The orbitals to be filled up are 4s, 3d and 4p. 2 electrons in the s orbital, 10 electrons in the 3d orbital and 6 electrons in the p orbital. In total 18 electrons and hence 18 elements in the fourth period. Fifth period, n is equals to 5. Orbitals to be filled up 5s, 4d and 5p. Again 18 electrons to be filled up and hence 18 elements in the fifth period. Sixth period, n is equals to 6. 6s, 4f, 5d and 6p orbital. S orbital can accommodate 2 electrons, f can accommodate 14 electrons. D orbital has 10 electrons and p 6. In total 32 electrons, hence 32 elements in the sixth period. Seventh period, it is still incomplete. Groups. The vertical columns of the periodic table are known as groups. In total, there are 18 groups numbered from 1 to 18. A group has series of elements having similar configuration of the valence shell. Now let me give you one example. Period, this is a second period from lithium to neon. Lithium, the valence shell electronic configuration is 2s1. Beryllium with atomic number 4, the valence shell electronic configuration is 2s2. Boron, atomic number 5, electronic configuration is 2s2 2p1. Carbon has valence shell electronic configuration 2s2 2p2. Nitrogen 2s2 2p3. Oxygen 2s2 2p4. Fluorine 2s2 2p5 and neon 2s2 2p6. Let us take an example of a group. Lithium, sodium, potassium, they are all alkali metals, the first group elements. Lithium, atomic number 3, electronic configuration 1s2, 2s1. Sodium, atomic number 11, electronic configuration 1s2, 2s2, 2p6, 3s1. Potassium, atomic number 19, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. From the electronic configuration, we can compare that they all have the similar valence shell electronic configuration and hence the similar properties and are grouped together in the first group. Now let me give you a quick recapitulation of the periodic table. The need for the classification of elements led to the formation of the modern day periodic table. The earlier attempts were based on the atomic weights, Dobronier triads and the Newland, the law of octaves. The remarkable attempt by Mendeleev, he gave Mendeleev periodic law. The properties of the elements are a periodic function of their atomic weight. This is Mendeleev periodic table. The 9 vertical columns called groups numbered from 1 to 8 and 0. Group 1 to 7 further subdivided into 2 subgroups as A and B. Group 8 consists of the 3 elements. Group 0 consists of the inert gases not discovered at the time of Mendeleev. 7 horizontal rows called series or periods from 1 to 7. Periodic table. Mendeleev, he said that the periodic table arranges all the elements in the groups according to their properties. The downward from top to bottom, that is groups. Horizontal rows are known as periods. Elements in the same group have the same number of electrons in the outer shell. This corresponds to their group number. All the group first metals have 1 electron in their outer shell. These elements have 3 electrons in their outer shells. These are the elements having complete outermost shell. As we move down through the group, an extra electron shell is added. Lithium has 3 electrons in the configuration. Sodium, atomic number 11, has 11 electrons and the configuration is 281. One extra shell is added. Potassium has 19 electrons in the configuration, 2881. Again, one more shell is added, but all these elements, lithium, sodium and potassium, have 1 electron in their valence shell, so they are all grouped in the same group, that is first group, known as the alkali metals. Modern periodic law by Henry Moseley. The physical and the chemical properties of the elements are the periodic function of their atomic number. The long form of periodic table, periods, horizontal rows. A period consists of a series of elements having same valence shell, total 7 periods numbered from 1 to 7. Groups. A vertical column of the periodic table is called a group. A group has series of elements having similar configuration of the valence shell. This is the modern periodic table. You can very well see the 7 periods and the 18 groups. Dear students, I hope and I am sure you all have understood the modern periodic table and all those historical attempts which led to its formation. Thank you so much.